Good day, everyone. Welcome back to General Chemistry 1. Today, we will be discussing limiting reactant and excess reactant. This is your mom, Jeremy Sagario, your lecturer for this topic. For this week, let us all be guided with our objectives. First is to identify the limiting and excess reagents in a given chemical reaction. Second is to calculate the amount of limiting reagent in the chemical reaction. And third is to calculate the amount of excess reagent that is not used in a given chemical reaction. How do we determine the limiting and excess reagents in a chemical reaction? To answer this, we can relate it through making a cheeseburger. In making a cheeseburger, we have here the following ingredients: bun, cheese, and meat. To understand the process, we have here a formula in making a cheeseburger. 1 bun plus 1 cheese plus 1 meat, we can create now 1 cheeseburger. Now, let's take a look if we have different quantities of ingredients. We have here 4 bun, 9 cheese, and 3 meat. How many cheeseburgers will be produced using the different quantities of ingredients? In this case, we can just create 3 cheeseburgers, even though there are still ingredients that can be used, such as the bun and the cheese. This is because the quantity of meat is not enough to match the amount of available bun and cheese. That's why the meat is the limiting reactant. Limiting reactant is the first reactant that is used up in the reaction. Take note that when limiting reactant is all used up, no more product can be formed and the reaction stops. Limiting reactant often isn't the reactant you have the least of. Instead, it is the first reactant to run out during the reaction. In a given sample, in making of cheeseburger, the first ingredient that ran out in the process is the meat. How about the remaining cheese and bun? These are the excess in making a cheeseburger. We still have 1 excess bun and 6 excess cheese. In a reaction, this is called to be the excess reagent or reactant, meaning to say bun and cheese in making a cheeseburger based from the given quantities, they are the excess. Excess reactant is what is left over after the reaction stops because the limiting reactant get all used. This reactant is the remaining quantities in a given reaction. Now, let's have some problems to calculate the limiting and excess reactant or reagent in a chemical reaction. For sample problem number 1, what is the greatest amount of magnesium oxide in moles that can be made with 7 moles of magnesium and 7 moles of oxygen gas? Which is the limiting reactant? Which reactant is in excess? And how many moles of it are left over? If we try to check, we have here 2 given values, the moles of magnesium and the moles of oxygen gas. And our unknown are the following: the greatest amount of magnesium oxide, the limiting reactant, the excess reactant, and the leftover. If we try to analyze the given problem, we can derive now the chemical equation, which is magnesium plus oxygen gas yield to magnesium oxide. If we try to observe, the given chemical equation is unbalanced That's why for step number 1, we need to write the balance equation for the chemical reaction. So we have here the unbalanced chemical reaction. First thing that we should do is to list the elements involved in the reaction and identify the number of atoms present in each element. So we have magnesium, which is 1, and oxygen, which is 2. These two elements are under the reactant side. In the product side, we have 1 magnesium and 1 oxygen gas. Now, if we try to observe, the amount of atom in the reactant side is 2. That's why the product side, oxygen, must also contain 2 atoms. So, under the magnesium oxide, we will now put 2 as its coefficient. So, we have magnesium 1 times 2 and oxygen 1 times 2. So the amount of oxygen in the reactant side and in the product side will be balanced already. How about in the magnesium side? For the magnesium, under the product, we have 2, while under the reactant, we have 1. So, under the reactant, we place 2 as the coefficient for us to have 2 magnesium under the reactant side. And since it is actually balanced, our final chemical reaction or formula will be 2 magnesium plus oxygen gas yield to 2 magnesium oxide. Again, we have here the problem and the balanced chemical equation. So for step number 2, we will determine the mole ratio of the reactants in the chemical reaction using the concept of stoichiometry procedure. In doing this, we need to ask these 2 questions. First, to use all of the magnesium, how many moles of oxygen gas do we need? So we will be looking for the amount of oxygen gas needed in the reaction. And to use all the oxygen gas, how many moles of magnesium do we need? So again, we will be looking for the needed magnesium amount to do or to complete the reaction. So, for the amount of oxygen gas, to calculate it, we will be using the amount of magnesium. So, here are the following values: 7.8 moles of magnesium, multiply it by 1 mole of oxygen gas over 2 moles of magnesium. Where did I get the 7.8 moles of magnesium? The moles of magnesium is actually indicated in the given problem. We have here 7.8 moles. How about the 1 mole of oxygen and the 2 moles of magnesium? We will be using the balanced chemical equation. As you can see, for every 1 mole of oxygen gas, we have 2 moles of magnesium. And take note that it is very important to cancel out the same unit for us to get or derive the main unit that we are looking for. So we will cancel out the mole of magnesium. Then 7.8, multiply it by 1 mole of oxygen gas, divide it by 2. The amount of oxygen gas needed in the reaction is 3.9 moles. Next, for the amount of magnesium, we will be using the amount of oxygen given in the problem. So this will be the values. 4.7 moles of oxygen, multiply it by 2 moles of magnesium over 1 mole of oxygen gas. Now, where did I get the 4.7 moles of oxygen gas? That value is actually present in the problem itself. So we have 4.7 moles of oxygen gas. How about the 2 moles of magnesium over 1 mole of oxygen gas? Again, we will be using the balanced chemical equation. Take note that for every 2 moles of magnesium, we have 1 mole of oxygen gas. Again, it is very important to cancel out the same unit for us to derive the proper unit that we are looking for. 4.7, multiply it by 2 moles of magnesium over 1 or divided by 1. The needed amount of magnesium is 9.4 moles. So for our third step, we need to compare the available ratio of moles of each reactant to the moles required for complete reaction. And take note, in this step, we will now be identifying the limiting and the excess reactant. Based from our solution in step number 2, we actually need 9.4 moles of magnesium to completely consume oxygen gas in the reaction. But take note, our available amount of magnesium is only 7.8 moles based from the given problem. And since the amount is not enough to consume all the oxygen gas because it is less than the required mole, therefore, magnesium will be our limiting reagent or reactant. How about the oxygen? So in our solution, in step number 2 again, we actually need 3.9 moles of oxygen gas to completely consume magnesium. Hence, the available amount of oxygen gas based from our problem is 4.7 moles, which is more than enough for the reaction to go completion. Therefore, oxygen gas will be our excess reagent or reactant because not all of its amount will be used in the reaction. So we have here again the problem and the balanced chemical equation. For step number 4, we need to solve for the greatest amount of the product to be produced. And take note that in solving for the greatest amount of product to be made, always use the value of limiting reactant because it will be the first reagent to be used up. And based from our problem, the limiting reactant is the magnesium. So, for the amount of magnesium oxide produced, we will be using the following values. We have 7.8 moles of magnesium, multiply it by 2 moles of magnesium oxide over 2 moles of magnesium. Now, where did I get the following values? For the 7.8 moles of magnesium, this is actually the available amount of magnesium that can be used in the reaction. And this value is actually indicated in the given problem. For the 2 moles of magnesium oxide and 2 moles of magnesium, we will now be using the balanced chemical equation. So for every 2 moles of magnesium oxide, we have 2 moles of magnesium. Now take note that it is very important to cancel out the same unit for us to get the main unit that we are looking for. So we cancel out mole of magnesium. Then 7.8 multiply it by 2 moles of magnesium oxide, divide it by 2. The greatest amount of magnesium oxide will be 7.8 moles. For our last step, step number 5, we need to solve for the leftover amount from the excess reactant. The leftover is the amount of the reactant not used in the reaction. And in the given problem, oxygen gas is the excess reactant in the reaction. For us to calculate the leftover amount of oxygen gas, we just simply need to subtract the amount used in the reaction from the available or given amount of the excess reactant. And these will be our values. We have 4.7 moles of oxygen gas, subtract it into 3.9 moles of oxygen gas. Now, where did I get the 4.7 value? This 4.7 is actually the available amount of oxygen gas based from the problem. And the 3.9 moles of oxygen gas is the needed amount of oxygen gas in the reaction, which is located or calculated under the step 2 of this procedure. Now, we subtract the 2 and the leftover amount of oxygen gas is 0.8 mole. So we have here the second sample problem. What is the greatest amount of AlCl3 in moles that can be made with 114 grams of aluminum and 118 grams of Cl2? Which is the limiting reactant? Which reactant is in excess? And how many moles of it are left over? So if we try to check the problem, we only have two given. We have 114 grams of aluminum and 186 grams of Cl2. And we have four unknown, the greatest amount of AlCl3, which is the product, the limiting reactant, the excess, and the leftover. So with this problem, we can come up with this equation. Al plus Cl2 yield AlCl3. If we try to check, the given chemical equation is unbalanced. That's why we need to write the balanced chemical equation for the chemical reaction. So we have here again the unbalanced chemical reaction. If we try to observe the Cl in the product side, it contains 3 atoms, while in the reactant side, it only contains 2 atoms. So for Cl, we will place 3 as the coefficient under the reactant side. So we have now 1 aluminum, we have 6 Cl, we have 1 aluminum, and we have 3 Cl. Since aluminum is the only balanced element both in reactant and in the product side, for the product side, we will place 2 as the coefficient for us to get 6 chlorine and 2 aluminum. And since the aluminum in the product side, I should say, has 2 atoms already, the aluminum under the reactant side, we will place now 2 coefficient for us to have now 2 aluminum. And since it is already balanced, our chemical formula or equation will be 2 aluminum plus 3 chlorine will yield into 2 aluminum chloride. So we have the step number 2 wherein we will convert the given grams of aluminum and Cl2 into moles. So for the moles of aluminum, this will be the following values that we will be using. 114 grams aluminum, multiply it by 1 mole of aluminum over 27 grams of aluminum. The 114 moles of aluminum is actually the given grams which is indicated in the problem. The 1 mole is a constant value wherein that for every 1 mole of aluminum, we have 27 grams of aluminum. The 27 grams aluminum is the atomic mass of aluminum which is located in your periodic table. We cancel out the same unit. So 114 multiplied by 1 mole of aluminum divided by 27, the moles of aluminum is 4.22. For the moles of Cl2, we will be using the following values. 186 grams of Cl2, multiply it by 1 mole of Cl2 over 70.90 grams of Cl2. 186 grams is the given grams of Cl2 which is indicated in the problem. For every 1 mole of Cl2, we have 70.90 grams of Cl2. Take note that chlorine has an atomic mass of 35.45 grams. And since we have 2 atoms of chlorine, we will multiply 35.45 into 2 for us to get 70.90 grams. We cancel out the same unit for us to bring out mole of Cl2. So we have 186 multiplied by 1 mole of Cl2 divided by 70.90. The moles of Cl2 is 2.62. For step number 3, we need to determine the mole ratio of the reactants in the chemical reaction. And in this part, we will be asking these two questions. For us to use up all aluminum, how many moles of Cl2 do we need? And to use up all Cl2, how many moles of aluminum do we need? Meaning to say, in step number 3, we will be looking into the needed amount of aluminum and Cl2 in the reaction. So, for the amount of Cl2, we will be using the following values. 4.22 moles aluminum, multiply it by 3 moles of Cl2 divided by 2 moles of aluminum. The 4.22 moles of aluminum is actually the converted grams of aluminum which can be located in the step number 2 of this problem. How about the 3 moles of Cl2 and 2 moles of aluminum? We will now be using the given balanced chemical equation that for every 3 moles of Cl2 we have 2 moles of aluminum. Then, we will now cancel out the same unit for us to bring out mole of Cl2 as our unit. 4.22 multiply it by 3 moles of Cl2 divide it by 2. The amount of Cl2 needed in this reaction is 6.33 moles. How about for aluminum? For the amount of aluminum, we will be using the following values. 2.62 moles of Cl2, multiply it by 2 moles of aluminum, divide it by 3 moles of Cl2. The 2.62 moles of Cl2 is actually the converted moles coming from the grams of Cl2 which is indicated in the problem. And we can get 2.62 moles from the step number 2 of this procedure. How about the 2 moles of aluminum and the 3 moles of Cl2? These two values are present in the balanced chemical equation. For every 2 moles of aluminum, we have 3 moles of Cl2. We cancel out the same unit for us to bring out mole of aluminum. So 2.62 multiplied by 2 moles of aluminum divided by 3. The needed amount of aluminum in this reaction is 1.75 moles. Okay, for step number 4, we will now compare the available ratio of moles of each reactant to the moles required for complete reaction. Take note, in this step, we will now be able to determine the limiting and the excess reactant based from the available amount and the needed amount. From our solution step number 3, the needed amount of Cl2 in this reaction is 6.33 moles and the available amount is 2.62 moles. The 2.62 moles is actually the converted moles of the grams of Cl2 present in the problem. And since the available amount is lesser than the needed amount, we can say that Cl2 is the limiting reagent or reactant. How about the aluminum? For step number 3 solution, the needed amount of aluminum is 1.75 moles and the available amount of aluminum is 4.22 moles. Take note, 4.22 moles aluminum is the converted grams of aluminum as indicated in the problem. And since the available amount is more than enough for the reaction, we can say that aluminum is the excess reagent or reactant. Okay, again we have here the problem. For step number 5, we will solve for the greatest amount of the product to be produced. And based from the given problem, we have aluminum chloride as our product. And in solving the greatest amount of the product, we will be using the values of the limiting reactant. So, for the amount of aluminum chloride produced, this will be the following values: 2.62 moles of Cl2, multiply it by 2 moles of aluminum chloride divided by 3 moles of chlorine 2. Now, where did we get the different values? So for the 2.62 moles of Cl2, it is actually the moles given based from the problem. How about the 2 moles of AlCl3 and 3 moles of Cl2? We will now be using the balanced chemical equation that for every 2 moles of aluminum chloride, we have 3 moles of Cl2. And then, we cancel out the same unit for us to bring out mole of aluminum chloride. So, 2.62 multiplied by 3 moles of aluminum chloride divided by 3, the amount of aluminum chloride produced will be 1.75 moles. So for step number 6, we need to solve for the leftover amount from the excess reactant. And based from our problem, we have aluminum as our excess reactant. And to solve the leftover amount of aluminum, we just simply need to subtract the used amount from the given or available amount based from the given problem. And this will be the values. We have 4.22 moles of aluminum, which is the available amount of aluminum in the said reaction, and the used amount is 1.75 moles. We subtract the two values and the leftover of aluminum is 2.47 moles.